Hey there, Mr. Sutton here with the AB Calculus 312 homework solutions on derivatives of inverse trigonometric functions. For number one, we've got the derivative that we want to take of arc cosine of 2x plus 1. So this is a pretty straightforward chain rule kind of problem. So we have the derivative of the outer function. Derivative of arc cosine, that's going to be negative 1 over the square root of 1 minus something squared, which in this case is 2x plus 1. But then we have to multiply by the tail of 2 for the derivative of the inner function here. So we had negative 1 over the square root of 1 minus that inner function squared. There's your tail. The most you can do on this one for simplifying is just move that 2 upstairs, and that's about as good as it gets. For number 2, we've got a chain rule involving arc sine as the outer function and 1 over x as the inner. So I'm going to start with the outer function derivative. That's going to be 1 over the square root of 1 minus this stuff squared. But then we have to multiply by the derivative of this inner function. This is really x to the negative 1. So our derivative then is negative x to the negative 2, which we can move upstairs, but that's really about all we can do here. For this problem, we want the derivative of this crazy-looking expression. So this is going to be quite the chain rule here. The outer function is something, cube root of something, rather. So this is really something to the 1/3 power, which I can write as, for the derivative now, 1/3 times all this stuff to the negative 2/3 power. So that's the derivative of cube root of something. Now we have to take the derivative of the something, of arc secant. So that's going to be 1 over the absolute value of negative 4x cubed times square root of 4x cubed squared minus 1. All that stuff. Now we have to multiply by the derivative of negative 4x cubed, which is going to be negative 12x squared. For number 4, we want the derivative of these arc functions. For arc cotan, we have negative 1 over x squared plus 1. And for arctan, we have positive 1 over x squared plus 1. Hey, wait a sec, those are the exact same thing with opposite signs. Well, that's just going to add up to 0. On number 5, we've got a chain rule involving arc cotan. So the outer function arc cotan, this is going to be negative 1 over this stuff squared plus 1. And then we have a tail of the derivative of this, which is 6x. And we can simplify this a little bit. So I'll put the 6x up top and make it negative. Downstairs, this will be 9x to the 4th plus 1. To take the derivative of this quotient, I'm going to need the quotient rule. So let me set up the box and ribbon. I've got my numerator, arc cosecant of 3x, denominator, which is x, and now the derivatives of these. For this one here, I'm going to need the chain rule. I've got arc cosecant of something, so the derivative of that is going to be negative 1 over the absolute value of something, so absolute value of 3x, and then the square root of something squared minus 1. So square root of, in this case, 3x quantity squared minus 1. And then we have to multiply by the derivative of the inner function. Derivative of 3x is just 3. We'll just put that up top. And now the derivative of x, much easier, that's just 1. So multiplying it out with the ribbon, I've got all of this craziness times x. So we'll call this negative 3x over all that stuff. And that's on top of a big fraction here. We're doing u prime v minus uv prime over v squared. So going the other way on the ribbon, this is the uv prime here. That's going to be arc cosecant of 3x times 1. And we're subtracting, so that's just minus arc cosecant of 3x. And then all of that's going to be over v squared, which in this case is going to be x squared. For number 7, we have a chain rule involving arc sine. So we'll start by making this 1 over the square root of 1 minus this stuff squared times a tail of 2x, because we have the inner derivative. So 2x can go upstairs, and we'll have 1 minus x to the 4th downstairs, and call it a day. On this problem, we want the derivative of arc cotan of radical x. So this is just a chain rule. We're going to have the derivative of arc cotan of something, which is negative 1 over 1 plus x squared. So in this case, negative 1 over 1 plus radical x squared. And then we have to multiply by the derivative of radical x. So this is really x to the 1/2 power, so its derivative is 1/2 x to the negative 1/2, and we're done. For number 9, we just want to know the slope of the tangent line for arctan of 4x at the point where x equals 1/4. So let's take our derivative here. This is going to require a small chain rule. So we've got 1 over this stuff squared plus 1 times a tail of 4 for that inner function. And we could simplify this a little bit. I'm going to put the 4 upstairs, but other than that, I'm just going to immediately plug in 1/4. And here's why. 4 times a fourth, well, that's just 1, right? 1 squared is 1. 1 plus 1 is 2. So we just have 4 over 2, which is 2. Choice A. Number 10 is a bit tricky. We're starting off with this crazy-looking limit here, and it equals 2, and we want to know what the value of A is. So the key to unraveling all this is to realize that this is just the limit definition of a derivative. So if you can figure out what the original function from all this is, and what they want you to plug into its derivative, then you just need to set all that equal to 2 and solve. So the original function out of this is going to be arcsine. That's what has the something plus h inside of it. Derivative of that would be 1 over the square root of 1 minus x squared, but they want us to plug a into that, so we'll have 1 over the square root then of 1 minus a squared. And they're saying that has to equal 2 for some value of a. Okay, well, let's go ahead and solve this. So first step to solving this, it'd be nice if this stuff was not in the denominator, so I'm just going to flip both sides of the equation, or you could multiply this over here and divide by 2. Either way, we've got square root of 1 minus a squared equals 1/2. Then I have to square both sides to get rid of the square root, so we have 1 minus a squared equals 1 over 4. Next, subtract 1. That'll be negative 3 over 4, and then divide by negative 1 to get positive a squared alone. So we have positive a squared equals 3/4, and then just square root both sides. So that's going to give us plus or minus square root of 3 over 2. Now looking at our answer choices, they said which of the following could be the value of a. Obviously, both of these answers are not up there, so we just pick the one that is up there, positive root 3 over 2. For number 11, this is just pretty much straightforward, go term by term and take the derivative kind of problem. So we need the derivative of tan inverse, which is also arctan. So that derivative is going to be 1 over x squared plus 1, or 1 plus x squared, either way. And then the derivative of 2 radical x. This is really 2 times x to the negative, or rather to the 1/2 power. So we're going to have 1/2 times 2 times x to the negative 1/2. And then x to the negative 1/2 is really just 1 over the square root of x, like I put here. That almost looks like something that's up there. Let's just cancel these 2's out. So we've got 1 over 1 plus x squared plus 1 over root x, and that is choice E. On this problem, we're just trying to find the derivative of arcsine of 2x. So this is going to require a little chain rule. We have arcsine of something, which is going to be 1 over the square root of 1 minus the something squared, so 1 minus 2x squared. And then we have to multiply by the derivative of the something, which is 2 in this case, the derivative of 2x. And if I wanted to, I could put this together and call this 2 over radical 1 minus all this stuff. A key change here is that this is going to become 4x squared inside here. So this is going to end up matching answer choice D. Yep, D.